Hi, 6th graders. Today we're going to look at multiplying decimals. At the end of this lesson, you want to be able to multiply decimals using standard algorithms. Let's start out if we're multiplying 8/10 and 7/10. We're going to find the product, which implies multiplication. We're going to use the hundreds grid to indicate that each square is 1/100th. So when we're looking at this, when I do 8/10, I'm going to do 8/10 across the top. So this would be 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, and 8/10. Okay, and then I'm going to switch colors. I'm going to go ahead and do 7/10 along the side. So we have 1, 2, 3, 4, 5, 6, 7. So now that we're looking at that, the real question becomes then, where have I colored twice? So I've colored twice in this area right here. So we could go through and count all of our squares, or we can think of it this way. Across the top here, we had 8/10, which was basically 8 squares. Along the side here, we colored 7 squares. 8 times 7 would be 56. But since each one of these squares represents 1/100th, there's actually 56 hundredths. So our final answer would be 56 hundredths. So some of you might be scratching your head and saying, well, that's kind of confusing. I don't really understand where you got how it became hundredths and you got a decimal point. We had squares colored in. When you're multiplying decimals, there's a few things that you should keep in mind. First of all, unlike adding and subtracting, the decimal points do not have to line up when you're multiplying. And the nice thing is you can multiply like the decimal point is not even there. Hence, if you go back to the other slide, when I multiplied 8/10 and 7/10, when I actually did the multiplication off to the side, I only did 8 times 7. Then what you're going to do is you're going to count the number of digits behind the decimal points in the factors, so the number is being multiplied, and that is the number that appear after the decimal point in the product. So going back to my original example from the last slide, 8 was behind a decimal point, 7 was behind a decimal point, so I multiplied 8 times 7 and got 56. Since I have a total of 2 numbers behind the decimal point, I go 1, 2, the decimal point has to be in front of 2 numbers in my product, so that's where we got 56 hundredths. Still confused? That's okay, let's look at another one. Let's just do 6 times 1/10. So I'm going to do 6, we're going to multiply by, I'm going to look for how many digits come after the decimal point in my factors. So in this case, my answer, I know would be 6, so my answer would be 6/10. So why don't you go ahead and pause the video and just try the next two out on your own and see how you do. In this next one, we have 1 and 25 hundredths. We're multiplying it by 23. 3 times 5 would be 15. 3 times 2 is 6, plus 1 is 7. 3 times 1 is 3. Notice, don't worry about decimal points, I'm just leaving them out. I have to add in my 0, because now I'm in the tens place. 20 times 5, or in this case, if you're looking at it this way, 2 times 5 would be 10, or 100. So we'd have our 1 up here again. 2 times 2 is 4, plus 1 is 5, and then 2 times 100 would be 200, or I mean 20 times 100 would be 2,000, so we have that 2 out here. We're going to add 5, 7, 8, 2. So right now it looks like our answer is 2,875. But I have to go back and look at my factors and count how many digits behind the decimal point. So here I have 2. Here I have no digits behind the decimal point. So I just need 2. So in my product, 2 digits behind the decimal point puts my decimal point in front of the 75. So my real answer is 28 75 hundredths. Alright, 1 2/10 times 1 6/10. 6 times 2, 12. 6 times 1, 6 plus 1 is 7. 1 times 2, 1 times 1. I'm going to go ahead and add 192. Once again, there's 2 digits behind the decimal point, so my answer would be 1 92 hundredths. When I went back to school shopping, I could buy notebooks for 75 cents. When I went to the cash register to pay for my 8 notebooks, the machine broke and we had to figure my total out by hand. Was the cashier correct if she charged me $6? So why don't you go ahead and figure this problem out on your own and see how you do. Okay, so we have 75 cents and we're multiplying it by 8. 8 times 5 is 40. 8 times 7 is 56, plus 4 would be 60. We have 2 digits behind the decimal point, so it has to go in front of the 2 zeros. Throw a dollar sign, it would be $6, so yes, she would be correct in the fact that she charged me $6. Another piece that we need to look at when we're multiplying decimals is actually multiplying by, it should be powers of 10. So let's look at a few examples. 3 25 hundredths times 10 is the same as 32 5 tenths. 3 25 hundredths times 100 becomes 325, and 3 25 hundredths times 1000 actually becomes 3,250. So you go ahead and pause the video and just kind of record what pattern do you notice as our powers of 10 increase, and then our products that we get. Hopefully when you're looking that you notice when you're multiplying by a power of 10, so 10, 100, 1000, 10,000, we are actually working in the base for our number system, meaning that our bases, every time we come to a group of 10, we can regroup. So think about your base 10 blocks, that's why they're called that. So you had 10 unit cubes, you could regroup it into a stick. The sticks can be regrouped into the hundreds block because that's our base 10. Every time we have 10 of something, we regroup. So a shortcut is actually to move the decimal point to the right for each 0 in our power of 10. So when you look up here, 10 had 1 0, so our decimal point went 1 space to the right. And 325, 2 zeros and 100, it went 2 spaces. And 1000, it went 3. So if you use that logic, if we had 3 25 hundredths and I multiplied it by 10,000, we would move 4 zeros. So it would go 1, 2, 3, 4, and we'd add in 2 other zeros. So we'd have 32,500. Just kind of a neat and handy little trick that can be useful.